let's look at some angles and the measurement of angles. So the first thing that we need to look at is, remember we talked about rays. Rays were those things that had an end point and continued forever. Well, two rays will create an angle. Now those angles can change. So like here is two rays and those angles change. So when we're thinking about this, I can have like a right angle and think about these continuing forever, this being my end point. So both of these rays would have the same end point. And we can measure these angles. Now we have to think about which angle we're measuring. Are we measuring this angle? Are we measuring the exterior angle or the interior angle? And we'll discuss those here in just a few moments. But we need to look at those different types of things. And so when we look at these, rays are angles that have sides, and they also have what we call the vertex. The vertex is this point right here where we can rotate it around. It's that common end point. So this right here is our vertex. So if I draw this right here is the vertex. It's where it changes. It can change. So I'm changing this around the vertex. Okay? And these arms, or these rays, are the sides. So this is a side and this is a side. Now, a moment ago I mentioned a name, and it was the interior of the angle. The interior of the angle is the inside. So it's this portion. The exterior of the angle is the outside of the angle. So this area here is the interior of the angle. And when we look at these, if I say that this is, I'm going to put a point A, B, and C, and then a lot of times we will put a line here, and maybe we aim at number 1. This angle can be labeled either angle B, because that's the vertex. It can be labeled angle ABC, because that's the order that we can go in. Now you'll notice that the B, the vertex, is in the center, so you have to go in order. You can't do A, C, B, or anything. The B has to be in the center. It can also be labeled as CBA, because you can go in the reverse order. Or this can be labeled as angle 1, because that's what I've labeled in here. Those are just different notations for the labeling of this particular angle. Adjacent angles are those that share a common vertex and a common side, but they don't overlap any interiors. So right here, I have adjacent angles. They have the same vertex. They share this side, okay, and they don't overlap. So this angle and this angle are completely separate, but they share the same side. And so we have interior, interior right here. That's all that adjacent means. It means they're side by side, but there's no overlap to them. Now, we use something called a protractor to measure the opening between the sides, opening of the angle. So, like if I have this angle here, I would measure, put this in my vertex, and I would measure the opening. Now, you'll notice that you have on your protractor, it goes from 180 here on the, it goes from 0 to 180 here. And then in the center, you can also see 10 to 170. Technically, it goes from 0 to 180 on the interior as well. And so it depends on which direction your angle is going. You can measure starting on the right-hand side and opening towards the left, or you can start measuring from the left and opening towards the right. So like if this angle is here, I could put my vertex here in the center. So I'd put my vertex right here, and I would line this side, this line up with my one side, and then I would measure using the inside, not the outside, because I'm starting on the right hand side. And so this angle would measure about 55. Okay. Now if I were to rotate it and move it this direction, I would start it here, line it up, and then measure using the outside numbers. And so this would measure about 77, because I would go to the center of these wide arms. And that's how you would use a protractor. Now, a complete rotation, meaning a circle, is 360 degrees. So I would have to put two of these together, because think about it, this is only halfway around, so that's a 180. So if I go the other halfway around, add that together, that's 360. Therefore, 1 degree is 1 over 360, or 1/360th of a full rotation. And we can use this in equal parts, and we can divide it into minutes, and we can divide it into seconds as well. When we do this, 60 seconds, 45 minutes, 60 degrees, 45 minutes, 3 seconds, you'll notice that the minutes have just an apostrophe, the seconds have the quotation marks. And in another video, we will do an example of how to do these conversions.